You know, we are standing right on the edge of a revolutionary shift in engineering. It's a change so fundamental, it's going to completely redefine the very materials we build our world with. So, let's dive in. Just imagine for a second, a bridge that can heal its own cracks after an earthquake. Or maybe an airplane wing that actually changes its shape mid-flight to get the absolute perfect efficiency. I know, it sounds like something straight out of a sci-fi movie, right? Well, what if I told you the materials to make all of this happen are already being developed? And look, this isn't just some cool thought experiment. This is the next great ambition in technology and engineering. The goal is to create a whole new wave of incredibly advanced products, especially for the industries where it matters most. We're talking aerospace, medicine, and energy. So the big question is, how do we get there? Well, the answer lies in completely rethinking the very building blocks of our world. We're talking about a future that is, in a word, optimized. And to get those safer, stronger, and, smarter products, we can't just make little tweaks here and there. No, this is a foundational transformation. It's one that has to start with a brand new class of materials.
So what is this magic ingredient? It's a category of technology with a bit of a mouthful of a name: nano-enhanced smart materials. So let's kind of peel back the layers on what that actually means.
Okay, so at its core, it's really a two-part idea. First, you've got smart materials. These are materials that can react to what's going on around them, things like heat, pressure, or light. Then you nano-enhance them. You embed these unbelievably tiny nanostructures inside, and that gives them incredible new abilities. And this is the really crucial part, the big takeaway. For all of human history, we've built things that just kind of sit there, passively. We are now moving to a world where we build things that actively participate. This is, without a doubt, the single biggest change these materials bring to engineering. I mean, for centuries, our structures have been passive, right? They're static, they're unresponsive, and they break down over time. It's just a fact. But nano-enhanced materials completely flip that script. They create systems that are active, adaptive, and even predictive. They can literally sense what's going on around them, respond to it, and get this, even predict and prevent failure before it even starts. Okay, that sounds amazing, right? But how in the world does the nano part of this give these materials what are basically superpowers? What is it about operating at this tiny scale that unlocks all these new capabilities? All right, it basically boils down to three key things. First, nanostructures have a massive surface area for their size. Think of it like having millions of tiny antennas packed into the material, which makes it incredibly sensitive to the smallest changes. Second, they allow for way faster, more precise responses. And number three, and this is the really wild one, they enable multifunctionality. This lets a single material do multiple jobs, like sensing it's been damaged and then starting a process to heal itself.
Okay, so enough with the theory. Let's talk about where this stuff is actually making a difference in the real world, because the applications are already starting to take shape across some major industries.
Take construction, for example. Picture this, self-healing concrete. We're talking about tiny little capsules embedded in the concrete that burst open when a crack forms and automatically repair the damage. I mean, the implications are just enormous, right? A future where our bridges and buildings need minimal maintenance could save trillions and dramatically increase safety. In aerospace, this tech allows for adaptive aircraft wings that can literally change their shape on the fly to be perfectly aerodynamic at any speed or altitude. That means massive fuel savings. Or think about your car. Smart coatings on the windows that can automatically adjust their tint to save energy on a hot, sunny day.
And honestly, the potential in medicine is where this gets truly revolutionary. Imagine smart drug delivery systems, where nanoparticles only release medicine at a very specific target, like right at a tumor. This makes treatments way more effective and with a lot fewer nasty side effects. Or think about implants that actively fight off infection. It's a total game changer for patient outcomes.
And of course, we can't forget energy and electronics. This tech leads to much better batteries and thermal storage, but it's also the key to those flexible, stretchable, even wearable electronics that we're all going to be using in the future.
Now hang on, because here's where it gets really mind-bending. When you combine these responsive materials with the brainpower of artificial intelligence, they don't just react anymore. They start making their own autonomous decisions. They can learn and adapt to complex, ever-changing conditions all by themselves. Okay, so as exciting as all of this sounds, and it is exciting,
we're not quite living in that future yet. To make this intelligent, adaptive world a widespread reality, the entire field really hinges on solving a couple of critical challenges.
There are two major hurdles that are pretty much going to define the next decade of research and development.
And these are the two areas that absolutely demand our focus if we want to move this technology from the lab into our lives.
First up is scalable manufacturing. You see, it's one thing to create a tiny sample in a lab. It's a completely different ballgame to produce these complex materials affordably and reliably on a massive industrial scale. And the second big one? Safety. We need incredibly strict safety standards. When you're engineering things at the nanoscale, you have to be absolutely certain the materials are safe for people and for the environment.
And look, solving these problems, it's not optional. It's absolutely non-negotiable, especially for tech that's going to be used in critical applications like medicine or aviation. Getting the manufacturing and safety right is essential to making this revolution a responsible one. All right, so let's do a quick recap of our journey here. We've seen the incredible promise of a world built with optimized products. We know the how is this fundamental shift from passive structures to active, intelligent systems, all powered by nano-enhanced smart materials. But to get there, we absolutely must clear the hurdles of manufacturing and safety first. And that really brings us to the final, big-picture question. We are on the cusp of an era where the physical objects all around us are no longer inert things, but are becoming intelligent and responsive. So the real question to leave you with is, as our physical world begins to wake up, what incredible new possibilities will we unlock next?